Alright, so I want to look at the empirical method and some of the tricks we can do with it. So the question I'm looking at here is a certain brand of automotive tires has a mean lifespan of 39,000 miles and a standard deviation of 2,400 miles. Assume that the span of tires has a bell-shaped distribution. So the lifespan of randomly selected tires are these, and we found the Z scores. But then it asks for the percentiles using these three values. And what we want to do is look at the empirical rules. So I'm going to bring this information over to my blackboard here, and we're going to look at what we can get out of this. So let me get a good color here. Make sure whenever I start doing this, I make sure. All right. And so in general, what we're looking at here is, let me bring my data over. So we have a mean of 39,000 miles. So I'll put over here, I think, my mean of 39,000 miles and a standard deviation of, I think it was 2,400. Let me look here. 2,400 miles. 2,400 miles. And my pencil's a bit better. Is that a better pencil? Yeah. Oh, that's better. I think that's a better size. All right, and so what we want to think about here is what this looks like in general, and then we'll put empirical rule things in place, and then we'll look at what's happening. So the mean in a bell curve is the middle, 39,000 miles. And then we kind of block out certain standard deviations. And so what we have here is, at the mean being in the middle, 50% is before and 50% is after. And so when you get up to here, if you're right at the 39,000, that's the 50th percentile. And then what happens with the empirical rule is that we have certain values that are in the middle. So in between these two values here, which is one standard deviation, let me put my standard deviations up here in a bright color. That's too bright of a color. Let's try that color. And so this is plus 1 standard deviation. This is plus 2 standard deviations. And this is plus 3 standard deviations. This is minus 1 standard deviation. This is minus 2 standard deviations. And this is minus 3 standard deviations. And so in the middle, there is 68.26%. 68.26% in between the one standard deviation. Then in this little bit that comes out ahead of it, now I'll change colors again. Here, that little bit is 13.59%. And this little bit here is 13.59 also. And then in this little bit here, I'm going to keep changing my colors so I can keep track of things, is 2.14%, and the same little bit over here is 2.14. And so what happens is, if we know where we are relative to the standard distribution, we can kind of add our ways forwards and backwards. And so what we kind of say is a general easy counting way of doing it is, we're going to round this down and we're going to say in between one standard deviation is 68%. In between two standard deviations, from there to there, is 95%. And then in between three standard deviations, the big wide thing out here, is 99.7%. And so if I need to find percentiles, I can kind of work my way around how much stuff is there. So if we look at the numbers that were given, and so I'll go back here and I'll make sure that we have all the numbers here. We wanted to know what percentile was 34,200. I'll write that one down. So our question mark is, where is 34,200 percentile wise? What was the other one? 43,000 and 39,000. Let me get that 43,000 right. It's 43,800 miles. And then in 39,000. And so what I do when I do any form of measure is I compare it to the standard deviation. And so in this case I look and I go, okay, or not, the number of standard deviations, I should say. And so I go, well, the mean is 39,000. Well, this is the mean. And so for 39,000, I can say it is at the 50th percentile, because that's where the mean is. And now I can count in standard deviations. And so when I come up one standard deviation, I get 2,400 more. So going up one standard deviation, I'll put my mean here, and plus one standard deviation gives me 41,400. Up two standard deviations gives me 43,800. Wait, oh, that's the number I wanted. So 43,800 is right here. And I need to figure out how much stuff is there. Well, if between here and here is 95% of the stuff, right? In between these two, well, then outside of it is 5%, with 2.5% here. So if I want to get all the way up to this bit here, if I start at 0% and I get all the way to 2.5 less than 100, well, this is the 97.5 percentile, the 97.5th percentile. And so 43,800 is the 97.5th percentile. Now, if I go the other way, if I go down, so minus one standard deviation from 39,000 brings me down to 36,600. I think 36,600. Let's see if I add 2,000. Yep. And if I go down two standard deviations, I'm going to go down to 34,200 and... oh, wait, that's the other number I was looking for. And so if I'm at this point here, let me choose a different color now. We'll go with bright blue. So if I'm here, and I want to count everything up to that line, well, if in between these lines where it's 95% and 5% is on either side, and I had 2.5 over here, well, this is going to be 2.5. And this puts it at this number at the 2.5th percentile. And so that's how the empirical rule works out and how it measures. We look for very specific standard deviations, and we know how much stuff is in between them. And so we put half of the remainder on either side and kind of count up and down. Gets some getting used to, but it's a quick way of looking at these without having to calculate the particular Z-score and some things that go back and forth with Z-scores we'll see later on, where we can get actual percentages if we know an exact Z-score. But that said, the empirical rule gives us a quick way of getting back and forth. We kind of have to remember that we're counting up from here, and so we can chunk off things away from 100 to get back down. And that because this is symmetric, if 68% of stuff is here, then in everything outside of this is the remaining, was it 32? And so there's 16% here and 16% here. And if 95% of the stuff is in between these two lines, then 5% is out here and 5% is out here. And if 99.7 is in between this line and this line, well, then you get 0.15 here and 0.15 here. So you get little bits and pieces everywhere. And so that's how the empirical rule helps us.